Hello guys, today it's the Scary Maths teacher, and in this video I will be showing you how to answer this question right here. It was given to me by a friend, and when I told them the correct answer they were quite shocked. And before I show you the solution to this question, what is the smallest number with 101 factors, I will show you a full derivation and some cool things about factors. So I hope you enjoy. Okay, so I'm not going to define factor, so I'm assuming you know what a factor is, of course. A factor is a factor of a number, for example n, is a number such that n divided by a factor of n will always result in a positive integer. Assuming n is a positive integer, of course. Always result in integer. Okay? That's what I'm gonna call a factor of n. Okay? So let's say we have a number such as 12 and we want to see how many factors this has. Well, we can do it the slow and boring method, which would be to just do it mentally. So 1, 2, 3, 4, 6 and 12. However, for a really large number, if I gave you this number and I asked you to calculate how many factors it had, it wouldn't really be that smart to do this and then count 1, 2, ... 6. That's not a very efficient method. I'm going to show you a slightly more efficient method. Okay, so let's say we have a number t such that its prime only has, in this prime factorization, it only has 2 primes. For example, p and q, and we see that p is raised to the 8th power and q is raised to the bth power. I'm just using p and q for now. You can extend it to more primes after I explain. I'm only using 2 for simplicity. Okay, well, what would the possible factors be? Well, what we can say is that all the possible numbers that can come from q of b would be q of 1 or q of 0, q of 1, q of 2, all the way up to q of b. This is like these are all the factors of q of b, right? So what we can say is that we can multiply p of a by every single one of these, okay, to get a factor. So what we can say is that for every single one of the factors of p of a, we can multiply it by the number of factors of q to the power of b to get a factor. So of course, we go from p to the 0th power to p to the 8th power. There's a plus 1 factors of this. And every single one of these a plus 1 factors can be multiplied by every single one of these to get a new factor. And then there are going to be b plus 1 here. So in the end, the number of factors for this p to the a plus times q to the b is just going to be a plus 1 times b plus 1. Okay, so think of it like this. We have all of the possible factors of p to the a. Since a prime number, all we can do is just split it up into prime, like itself. And then this p of 0, for example, it can go into q of 0, it can go into q of 1, and by multiplying this, we get b plus 1 factors. Now with the next one, p of 1, we get b plus 1 factors. With p to the power of 2, we get b plus 1 factors. And we can do this all the way up to a to get a plus 1 altogether. A plus 1 times b plus 1. That's our formula, right? So let's say we have another prime number, for example, another number t, which is just p to the a times q to the b times r to the c. It would just be a plus 1 times b plus 1 times c plus 1. This is how we determine factors, right? We split it up to its prime factorization and add 1. Then by doing this, we get how many factors the number has. It's pretty cool, right? Okay, so for example, with our original number 12, we know that it has 6 factors. We can just split 12 into its prime factorization, 3 to the 1 times 2 squared. 1 plus 1 times 2 plus 1. 2 times 3, 6. It works. Let's take another number, 35. It only has 4 factors. 1, 5, 7, 35. Right? We can also do that. 5 to the 1 times 7 to the 1. 1 plus 1 times 1 plus 1. 2 squared, 4. Okay? So it's clear that this method works. Right? And it can be useful at times. So now let's get back to our original question. We know that our formula would just be a plus 1 times b plus 1 times c plus 1 dot dot dot. Of course, if we have a number where, for example, it's only 2 numbers, for example, p to the a times q to the b times r to the c, but we don't care about the r, then the c would just be 0. Just like for every single other prime number out there, we could also let d be we could let d be for another prime number, but then d would just be 0 because there's 0 of that prime number. So we could argue that this is infinitely long, but eventually there'll be infinitely many which we just cancel out or don't care about. So yeah, it doesn't matter, right? So of course we're saying this dot 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 multiplies to make 101. Okay, that's our question. We need to find the smallest number such that this happens, right? But the only thing is 101, it's prime. Which means to make 101, one of these has to be 101. And then the rest has to be 1, right? So know that it's really just one prime number p to the power of a, or to the power of 100 would just have 101 factors, right? For example, if you wanted a number with 37 factors, we really could just take a prime number and take it to the 36th power. But that's what we could do. Or if you wanted a number with 20 factors, we could do a prime number to the power of 19. But for a number like 20, that's not very efficient. Because 20, we can split that into 5 and 4. So we can take one prime number to the power of 4 times another prime number to the power of 3 and get a way smaller result than taking a prime number to the power of 19. However, since 101 is prime, we can't split it up. So the smallest solution is a prime number to the power of 100. Now the smallest prime number is 2. So our optimal solution for 101 would be 2 to the 100. This is the smallest number with 101 factors. Pretty cool, right? 101. It's 2 to the 100. Now that's a very big number, 2 to the power of 100. If you think about it, that's 2 to the 10 to the 10. And if you think about what 2 to the 10 is, imagine taking that to the 10th power. 2 to the 10, I'm pretty sure that's 1024. That's basically 10 cubed to the 10th, basically. So that's like 10 to the 30. It's greater than 10 to the 30. That's how big it is. So, remember, if you have any prime number p, the smallest number with p factors is 2 to the p minus 1. And there will of course be infinitely many numbers with that, because then you'd have 3 to the p minus 1, 5 to the p minus 1, and the list goes on, right? You could even get p to the p minus 1. And that would also have p factors. So, yeah. Pretty cool. Yeah. Well, I hope you enjoyed this short explainer video. From this logic, you can like derive HCF or LCM and think, you know, HCF times LCM, like HCF of AB times the LCM of AB equals AB. You can do stuff like this. If you just play around with numbers and think, every single number can be written as, for example, P1A1 times the second prime A2 dot dot dot. Then you can think, okay, we have a second number B where we can do the same. For example, Q1B1 times Q2B2, and then think, okay, some of these must match, and then use the same logic. You can do a lot. I think prime factors are something really cool. When you first learn them in school, you think, okay, well, I'm never going to use that. But you can. There's so many uses, especially in number theory and so many modern algorithms which we use to calculate things rely a lot on prime numbers. Like, without ever discovering all these theorems about prime numbers, we probably wouldn't have gotten almost anywhere. They are fundamental to mathematics. Yep, fundamental. That's why the fundamental theorem of algebra is literally about prime numbers. I mean, not algebra, of arithmetic, but yeah. I hope you enjoyed that, and bye!